Hello everyone, I'm CH Lokesh. In this presentation, I'm going to tell about ergodic process. Before knowing ergodic process, we have to know about ergodic theorem. The theorem states that for any random process x of t, all the time averages of the random signal x of t are equal to the ergodic averages of the random process x of t. So that is the time average is equal to ensemble average, and time autocorrelation is equal to ensemble autocorrelation. So if any random process is a, is obeys the ergodic theorem, then the process is known as ergodic process. Introduction to ergodic process. So we have already seen that an ergodic process is a type of stochastic or random process in which the time averages are equal to its ensemble averages. So in simple terms, observing one sample of the process over a long time gives the same results as the observing many samples at one instance. For example, take the fans in your room as an example. So consider all consider the average speed of all the fans at any point of time. If that is equal to the average speed of a single fan in the room over the period of time, then the random process is said to be ergodic random process. The meaning of ergodicity. Ergodicity means that the statistical properties of a process can be determined from a single realization over time. It ensures that the process is time invariant in its statistical behavior. Classification of random process. Random processes are generally classified into stationary and non-stationary, and another classification is ergodic and non-ergodic. So ergodicity is a special property often applied to stationary process. So we know what are stationary processes. So a, pro a process is said to be stationary if all its statistical properties such as mean, variance, and autocorrelation are independent of time instance. Time instance. So the remaining are non-stationary, and another classification is ergodic and non-ergodic. We have already seen what is the term ergodic mean. Stationary versus ergodic process. A stationary process has statistical parameters. So the statistical parameters are mean, variance, autocorrelation, and these are constant over time. And an ergodic process is a stationary process where time averages equal ensemble averages. So for example, let x of t be a random variable. The process is ergodic if only the mean is equal to limit t tends to infinity 1 by t into integral x of t dt is equal to expectation of x of t. So the autocorrelation function is equal to limit t tends to infinity into 1 by t integral x of t into x of t minus tau dt. This is equal to x of t into x of t minus tau. So this formula shows that the average of the random process, and this is expectation of expectation of the random process. So we know the expectation of the random process is equal to the mean, and the autocorrelation function as t tends to infinity is given here, and we can write like this by using the expectations. So types of ergodic process. First one is mean ergodic process, and another one is autocorrelation ergodic process, and third one is cross correlation ergodic process. And a random process is said to be mean ergodic process if the time average of the random process is equal to the ensemble average of the random process x of t. And a random process is said to be an autocorrelation ergodic process if the time autocorrelation is equals to the ensemble autocorrelation. And a random process x of t is said to be cross correlation ergodic process when the time average of cross correlation is equal to the ensemble average of the cross correlation. Mean ergodicity. The process x of t is mean ergodic if the time average mean equals to the ensemble mean. And the equation is limit t tends to infinity of 1 by t into integral x of t dt is equal to expectation of x of t. So we have limit t tends to infinity here since we observe the event up to time infinite or range of time. So that's why we put t tends to infinity here. Then this indicates the time average of the random process x of t, and the expectation x of t indicates the ensemble average of the random process x of t. And the expectation of x of t indicates the ensemble average indicates that only we're observing it all the particular events, all the existing events at only one particular time. This means that observing one signal over time gives the same mean as multiple signals observing at one partic one particular time instant. The autocorrelation ergodicity. A process is autocorrelation ergodic if the limit t tends to infinity into 1 by t integral x of t into x of t plus tau dt is equal to expectation of x of t into x of t plus tau. So this limit t tends to infinity 1 by t into integral x of t into x of t plus tau dt indicates the time autocorrelation, and the expectation of this indicates the ensemble autocorrelation. This ensures the time correlation matches the ensemble correlation. If this condition is approved, then the autocorrelation is ergodic autocorrelation. Cross correlation ergodicity. A process is cross correlation ergodic if limit t tends to infinity into 1 by t into integral x of t into y of t plus tau dt is equal to expectation of x of t into y of t plus tau. This ensures the time correlation matches the ensemble correlation. And we can, instead of writing all the limit t tends to infinity and all this stuff, we can, instead of writing all this, we can simply write a of this term. So the a of x of t into y of t plus tau is equal to e of x of t into y of t plus tau. Then this ensures the time correlation matches the ensemble correlation. So importance of ergodic process. So the ergodic process, it simplifies analysis of random signals and it helps in signal processing and communications. It is used to model noise and other stochastic behaviors, and it reduces the need for multiple realizations. So this is the ergodic theorem, and we have already seen what is ergodic theorem is. The ergodic theorem states that for ergodic process, time average convert to ensemble average. This is the foundational concept in probability and stochastic process. And we have already seen about ergodic process. So examples of ergodic process. So one is white noise process, which has zero mean and constant power. And second one is certain Markov process. Third one is random binary signals with equal probability. And last one is stationary Gaussian process. Non-ergodic process. In non-ergodic process, time averages and ensemble averages are not equal. So I have seen in an ergodic process, both time averages and ensemble averages are equal. So in non-ergodic process, the time averages and ensemble averages are not equal. For example, random process with the time varying mean or variance. And this violates the property of stationary process, and if the process is not stationary, then it's not ergodic also. Such processes cannot be analyzed using a single realization. Applications of ergodic process. Ergodic process are used in communication system for noise modeling and in control systems. These are used in signal processing and in statistical mechanics and reliability and queuing theory. Conclusion. Ergodic Ergodic process simplify the study of random phenomena by allowing time averages to represent ensemble behavior. They are crucial in analyzing stationary random process in engineering and science.